Look up into the night sky, and you are looking at an illusion of order. We have spent centuries constructing a magnificent cathedral of mathematics to explain the mechanics of the cosmos. We weighed the burning cores of distant stars, calculated the trajectory of ancient galaxies, and mapped the invisible bending geometry of space itself. We convinced ourselves that we had finally decoded the foundational language of reality. The equations were elegant, tying together gravity, light, and time into a neat, predictable package. The models made perfect sense. The universe, we believed, was a clockwork mechanism governed by absolute, immutable laws. But that cathedral is currently collapsing beneath the weight of new evidence. There is a crack in the foundation of modern physics, a fundamental discrepancy in the very numbers that dictate how the universe behaves at its most colossal scales. For years, astrophysicists whispered about a strange anomaly in the dark. They noticed that the fabric of the cosmos was expanding in a way that directly defied the standard model of cosmology. The measurements were conflicting. The math simply refused to balance. For a long time, the scientific community dismissed it as a simple error in our own instruments. They called it a calibration glitch, a smudge on a telescopic lens, or a miscalculation born from the atmospheric distortion of our own planet. We assumed that once we launched a clearer, more powerful instrument into the cold, dead vacuum of deep space, the error would naturally correct itself. The universe would align with our comforting theories once again. We spent decades building a $10 billion instrument of gold-plated beryllium mirrors, launching it 1 million miles away from Earth just to seek that exact reassurance. We pointed it toward the most ancient light in existence, fully expecting a definitive confirmation of the laws of physics that we had taught in universities for nearly a century. Instead, the data returned, and it delivered a death sentence to our current understanding of reality. The anomaly is not a mistake. It is absolutely real. The machinery of the cosmos is operating under rules we do not comprehend, pulling itself apart at a speed that suggests either our entire framework of physics is fundamentally broken, or there is an unseen, terrifying force actively reshaping the void around us. We are standing on the edge of a monumental paradigm shift, staring into a dark expanse that is fleeing from us faster than it has any right to. If you seek the truth in the dark, if you want to understand the profound mysteries of a universe that is completely indifferent to our existence, subscribe and join us on this journey. We are about to dismantle the illusion of order, to understand the terrifying gravity of what the latest data has just confirmed. We must first look back at the precise moment humanity realized the sky was not a static ceiling, but a violent, stretching fabric. To understand the sheer magnitude of the crisis currently paralyzing astrophysics, we must first dismantle the greatest liability we possess: our own common sense. Human intuition is a terrestrial survival mechanism. It was forged over millions of years by the slow, predictable physics of a small, rocky planet orbiting a painfully ordinary yellow star. Our brains evolved to calculate the trajectory of a thrown spear, to anticipate the fall of an apple, and to navigate distances measured in footsteps and horizons. We are biologically hardwired to expect that an object at rest will remain at rest. That space is merely an empty room in which things exist, and that time is a steady, unyielding river flowing evenly for everyone. We intuitively believe that the universe is a stable stage, a rigid theater where the drama of existence plays out under fixed, unchanging dimensions. This intuition is not just flawed, it is a profound, biological delusion. For most of human history, this delusion was enshrined as absolute scientific truth. When Isaac Newton formalized the laws of motion in the 17th century, he cemented the idea of absolute space and absolute time. In the Newtonian framework, the universe was an infinite, static grid. Space was a silent, unmoving void, and time ticked forward with the mechanical precision of a divine grandfather clock, identical in all corners of the cosmos. This gave humanity a deep, psychological comfort. It implied that the universe, while vast and cold, was ultimately a stable machine. The stars might burn and die, planets might trace their elliptical orbits, but the stage itself, the empty canvas of reality, was permanent and still. We believed we were living in an architectural triumph of absolute geometry. Even when Albert Einstein shattered Newtonian physics in the early 20th century, the desperate human need for a static universe persisted. Einstein's theory of general relativity was a violent conceptual revolution. It demanded that we stop thinking of space and time as separate, rigid entities. Instead, he proved that they were woven together into a single, pliable fabric called space-time. Space was no longer an empty room. It was a trampoline, a responsive medium that could warp, bend, and sag under the immense weight of stars and galaxies. Gravity was not an invisible tether pulling objects together, but rather the geometry of space itself, curving, forcing planets to roll along the invisible indentations created by massive celestial bodies. Yet, despite handing humanity the mathematical keys to a dynamic, twisting universe, Einstein himself was terrified by what his own equations implied. When he applied his brilliant new mathematics to the universe as a whole, the numbers screamed an impossible reality. The equations of general relativity proved that a universe filled with matter could not simply sit still. Because every galaxy exerted a gravitational pull on every other galaxy, the entire fabric of reality should be highly unstable. The math dictated that the universe must either be collapsing inward upon itself under its own weight, or expanding outward. A static, hovering universe was mathematically impossible. It was like balancing a needle on its point. The slightest perturbation would cause the entire system to crash. Einstein, heavily influenced by the philosophical dogma of his time, recoiled from his own genius. He could not accept a universe in motion. To force the cosmos to hold still, he introduced an arbitrary mathematical patch into his equations. He called it the cosmological constant. It was a theoretical, invisible, repulsive force acting perfectly against the crush of gravity. A mathematical wedge shoved into the gears of his own theory to keep the universe artificially frozen. It was a desperate attempt to save the illusion of a quiet, eternal sky. He would later call it the greatest blunder of his life. Because while Einstein was busy trying to mathematically paralyze the cosmos in his office, the physical universe was already preparing to reveal its terrifying true nature on a freezing mountaintop in California. In the 1920s, humanity's perspective of the dark underwent a violent expansion. At the Mount Wilson Observatory, staring through the massive 100-inch Hooker telescope, astronomers Vesto Slipher and Edwin Hubble were systematically destroying the static universe. Night after night, in the freezing high-altitude air, they exposed photographic glass plates to the faint, ghostly light of distant nebulae. At the time, astronomers still debated whether the Milky Way was the entirety of the universe, or if those faint cloudy smudges of light were actually island universes, entire galaxies swimming in an ocean of unimaginable emptiness, located far beyond our own. Hubble not only proved that these nebulae were isolated galaxies containing billions of stars, but he and his colleagues began dissecting the very anatomy of the light radiating from them. To do this, they did not just look at the galaxies, they broke the light apart using spectroscopy. When starlight passes through a prism, it smears out into a rainbow spectrum. But this spectrum is not perfectly smooth. It is interrupted by absolute black lines, like a cosmic barcode. These dark gaps are absorption lines, created when the light passes through the cooler gases in the outer atmosphere of a star. Every chemical element, hydrogen, helium, carbon, absorbs very specific, exact wavelengths of light. This means the pattern of black lines is a flawless, unforgivable chemical fingerprint of the galaxy being observed. But when Slipher and Hubble analyzed the light from these distant galaxies, the fingerprints were wrong. The barcodes were distorted. The pattern of the black lines was identical to the elements we know on Earth, but the entire sequence was shoved drastically toward the red end of the light spectrum. This phenomenon, known as redshift, is the visual equivalent of a deeply unsettling audio illusion. If you stand on a sidewalk and an ambulance drives past you, the pitch of the siren sounds violently compressed and high-pitched as it approaches, and then deeply stretches into a lower, mournful pitch as it speeds away. This is the Doppler effect. The waves of sound are being physically compressed or stretched by the motion of the vehicle. light behaves the exact same way. If a galaxy is rushing toward us, its light waves are compressed, shifting the color toward the blue end of the spectrum. But if a galaxy is fleeing from us, the light waves are stretched out, dilating the wavelengths and shifting the entire chemical barcode toward the red. Almost every single galaxy Hubble observed was redshifted. They were all moving away from us. But the true horror of the discovery was hidden in the mathematical correlation. Hubble realized that the dimmer and smaller the galaxy appeared, meaning the farther away it was, the more severely its light was stretched into the red. The relationship was shockingly linear. A galaxy twice as far away was receding twice as fast. A galaxy 10 times further away was fleeing 10 times faster. This was the death blow to human intuition. If everything is moving away from us, and the speed of their retreat increases with distance, it does not mean that the Earth is at the center of a cosmic explosion. It means something far more profoundly disturbing. Imagine you are standing in the middle of a sprawling, infinite city at midnight, surrounded by distant streetlights in every direction. Suddenly, you realize that every single streetlight is moving away from you. The lights a mile away are receding slowly. The lights 10 miles away are rushing away quickly. The natural assumption is that you are the epicenter of a blast. But if you were to instantly teleport to any of those distant streetlights and look back, you would see the exact same thing. Everything, everywhere, is moving away from everything else. The galaxies themselves are not physically flying through pre-existing space like shrapnel from a bomb. The terrifying reality is that the empty space between the galaxies is physically multiplying. The fabric of the universe itself is stretching. This realization permanently altered the trajectory of human thought. The universe was not a static architectural structure. It was an inflating balloon, a swelling dynamic entity. And if the universe was expanding today, basic logic dictated that in the past it must have been smaller, denser, and infinitely hotter. Run the clock backward far enough, and everything collapses into a single, infinitely dense point. The discovery of expansion inadvertently gave birth to the concept of the Big Bang. We realized that reality had a definitive beginning, a violent inception point, and that we were currently living in the cooling, expanding wreckage of that ancient event. To make sense of this new, terrifying reality, astrophysicists needed a rulebook. They needed a mathematical anchor to describe the exact mechanics of this cosmic stretching. They developed a simple, elegant equation to measure the pulse of the expanding void. It became known as the Hubble constant. The Hubble constant is, in theory, a single, straightforward number. It represents the exact rate at which the universe is expanding at this current moment in cosmic history. It is the fundamental speed limit of the stretching void. If you know the distance to a galaxy, you multiply it by the Hubble constant, and it tells you exactly how fast that galaxy should be receding from you. For nearly a century, calculating this specific number became the holy grail of modern astronomy. Finding the exact value of the Hubble constant meant understanding the ultimate destiny of the universe. If the number was high, the universe was flying apart violently and would eventually rip itself to shreds. If the number was low, the expansion was sluggish, perhaps meaning the gravitational pull of all the matter in the cosmos would eventually hit the brakes, halting the expansion and dragging everything back into a catastrophic, crushing collapse. It was a matter of celestial accounting. We believed that reality was governed by this single, measurable metric. The mission was clear: build better telescopes, observe further into the darkness, measure the redshift of older galaxies, and nail down the exact value of the Hubble constant. We expected the math to converge. We expected different methods of observation to eventually point to the exact same number, cementing our mastery over the mechanics of space-time. We assumed that once we had the right tools, the universe would yield its final static truth. For decades, we launched increasingly sophisticated glass and beryllium eyes into orbit, staring deeply into the cosmic microwave background, the residual, frozen afterglow of the Big Bang itself. We measured the radiation left over from the dawn of time, mapping the microscopic temperature fluctuations of the newborn universe. From this ancient, fossilized light, our most brilliant theoretical physicists constructed the standard model of cosmology. It was a masterpiece of human intellect, a robust, unbreakable mathematical framework that predicted exactly how the universe should behave, how galaxies should form, and crucially, exactly how fast the universe should be expanding today, based on how it began. The theoretical models provided a very specific, undeniable prediction for the Hubble constant. The number was established, the foundation seemed secure. But as we refined our instruments to measure the actual, physical universe around us, we stopped looking at the ancient fossil light and began measuring the actual movement of stars currently burning in our local modern cosmos. Shadow began to fall over the mathematics. The measurements taken from the living, breathing universe around us did not match the immaculate predictions of the early cosmos. At first, the discrepancy was small enough to ignore. A fraction of a millimeter in the cosmic machinery. The scientific community, desperate to maintain the illusion of order, blamed the tools. They blamed the atmospheric distortions, the limitations of the lenses, the inherent margin of error in calculating the distance to a star burning millions of light years away. They assured themselves that as the instruments grew more powerful, the data would inevitably correct itself. The local measurements would surely fall in line with the theoretical predictions. The universe, they believed, was fundamentally logical, but the tools grew sharper. The errors were eliminated. The measurements became violently precise, and the discrepancy did not disappear. It grew. It hardened into an undeniable mathematical wall. The numbers we were extracting from the dark were beginning to reveal a schism in the very architecture of reality. A fundamental contradiction that suggested our understanding of the void was not just incomplete, but profoundly, catastrophically wrong. To comprehend the sheer scale of the nightmare that astrophysicists are currently facing, we have to look at the mechanics of how we actually measure the void. It is a problem of arrogant proportions. You cannot simply lay a ruler across the cosmos. We are confined to a tiny, insignificant rock, floating in the unfathomable depths of an expanding ocean, trying to calculate the exact dimensions of an abyss that we can never physically traverse. The only tool we have at our disposal is light. Ancient, exhausted light that has traveled for millions, sometimes billions of years, just to die on the lens of our telescopes. We have to capture these dying photons and extract their secrets, reverse engineering the history of the universe from a few fragile beams of radiation. For decades, the astronomical community constructed a massive, intricate system to measure these incomprehensible distances. They called it the cosmic distance ladder. It is a masterpiece of logical deduction, a series of overlapping mathematical techniques where each step outwards relies entirely on the absolute perfection of the step that came before it. The first rung of this ladder is simple geometry. It is a phenomenon called parallax. As the Earth orbits the Sun, our vantage point in the solar system shifts by roughly 186 million miles over the course of 6 months. If you look at a relatively close star in January, and then look at that exact same star in July, the star will appear to have shifted slightly against the background of much more distant, stationary galaxies. By measuring the angle of that microscopic shift, we can use basic trigonometry to calculate exactly how far away that star is. It is the exact same optical mechanism your brain uses to judge depth when you close one eye and then the other. But parallax has a hard, physical limitation. It only works for our immediate cosmic neighborhood. Once you try to measure stars that are thousands of light years away, the apparent shift in their position becomes so infinitesimally small that no telescope engineered by human hands can detect it. The angle vanishes into nothing. To measure the deeper universe, we had to find a new rung on the ladder. We needed a way to calculate distance, not by geometry, but by brightness. Imagine you are standing on a blacked-out coastline, looking out over a foggy, infinitely vast ocean. You see a light in the distance. You have no way of knowing if that light is a powerful lighthouse 10 miles away, or a dim flashlight held by someone on a boat just a few hundred feet offshore. Without knowing the true absolute power of the light source, estimating its distance is impossible. But if you knew, with absolute certainty, that every single lighthouse on that ocean used the exact same bulb, generating the exact same wattage. You could easily calculate their distances. The fainter the lighthouse appeared to your eye, the further away it had to be. The inverse square law of light would do the math for you. Astrophysicists call these predictable lights standard candles. And the discovery of the first true standard candle in the universe is perhaps the most crucial breakthrough in the history of observational astronomy. It was not made by a man staring through a massive telescope on a mountain, but by a brilliant, relentless woman named Henrietta Swan Leavitt, working in a cramped, noisy room at the Harvard College Observatory in the early 1900s. Leavitt was employed as a human computer, tasked with analyzing thousands of glass photographic plates of the Magellanic Clouds to dwarf galaxies orbiting our Milky Way. She was studying a very specific, bizarre class of stars, known as Cepheid variables. These stars are not stable. They are massive, volatile, and dying. They physically inflate and deflate, swelling up and collapsing in a rhythmic, mechanical cycle. They pulse, and as they change in size, their brightness fluctuates with the steady, predictable rhythm of a cosmic heartbeat. Leavitt painstakingly measured the varying brightness of hundreds of these pulsing stars, tracking the exact length of time it took for each one to complete a full cycle from bright to dim to bright again. What she discovered was a flawless mathematical law hidden in the chaos of burning plasma. She realized that the slower a Cepheid variable pulsed, the brighter the star intrinsically was. It was an ironclad relationship. If you found a Cepheid pulsing once every 30 days, you knew exactly how much raw light it was pumping out into the void. And if you knew its true luminosity, you could compare it to how dim it appeared from Earth, and instantly calculate its exact distance. The underlying physics driving this cosmic metronome is violently complex. It is a massive thermodynamic engine operating in the outer layers of the star, driven by the ionization of helium. As the star's gravity pulls its outer layers inward, the immense pressure causes helium atoms to lose their electrons. This ionized helium becomes incredibly opaque, trapping the radiation pouring out from the star's nuclear core. The trapped heat builds up tremendous pressure, forcing the entire star to violently expand outward. But as the star expands, it cools down. The electrons recombine with the helium. The gas becomes transparent again. The trapped radiation escapes into space, and the star deflates back under its own gravity, starting the cycle all over again. It is a self-regulating, mechanical valve made of plasma, beating in the dark. By finding Cepheid variables in distant galaxies, astronomers could finally measure the expanding universe. They could determine exactly how far away a galaxy was, measure how drastically its light was stretched into the red by the expansion of space, and calculate the speed at which it was fleeing from us. But even Cepheid variables have their limits. They are incredibly bright, but eventually, the universe becomes so deep and so dark that even the slow, powerful pulse of a massive Cepheid is swallowed by the distance. To measure the very edge of the observable universe, we needed a much larger bomb. We needed a standard candle so violent that it could outshine an entire galaxy of 100 billion stars. We found it in the thermonuclear detonation of dead stars. We found the type Ia supernova. This is the next and most crucial rung on the cosmic distance ladder. A type Ia supernova is not a normal star dying. It is a parasitic relationship between two stars locked in a tight binary orbit. One of them is a white dwarf, the incredibly dense, crushed, dead core of a star that ran out of nuclear fuel long ago. It is a sphere of pure carbon and oxygen, roughly the size of the Earth, but containing the mass of the Sun. The gravity on its surface is millions of times stronger than what we experience. This dead, rotating husk exerts a terrifying gravitational pull on its living companion star, slowly siphoning away its outer layers of hydrogen gas, pulling a river of plasma across the vacuum of space. The white dwarf feeds. It gorges itself on the stolen gas, growing heavier and denser over millions of years. But the laws of quantum mechanics dictate a strict, unbreakable limit to how massive a white dwarf can become. It is called the Chandrasekhar limit, calculated at exactly 1.44 times the mass of our Sun. As the white dwarf steals matter and approaches this exact mathematical boundary, the pressure in its core reaches a critical threshold. The temperature spikes to billions of degrees, and the dormant carbon within the dead star suddenly ignites. Because the star is supported by quantum degeneracy pressure rather than thermal pressure, it cannot regulate itself. It expands to cool down. Instead, the carbon fusion triggers a runaway thermonuclear chain reaction. A deflagration wave tears through the star at a fraction of the speed of light, incinerating the entire white dwarf from the inside out in a matter of seconds. It is a bomb of absolute, unfathomable proportions. But the terrifying violence of this event is exactly what makes it scientifically priceless. Because every single white dwarf detonates at the exact same mass limit. Under the exact same physical conditions, every type Ia supernova in the universe produces the exact same peak luminosity. They are the ultimate standard candles. When one of these detonations goes off in a galaxy billions of light years away, it briefly shines brighter than everything else in the sky. By measuring how faint that explosion appears from Earth, we can calculate distances spanning the vast majority of the observable cosmos. This is how we measure the local, modern universe. We use parallax to calibrate the Kephidas. We use the Kephidas to calibrate the supernova. We use the supernova to measure the deep void. We map the distance to these celestial bombs. We measure how fast they are receding from us due to the stretching of space. And we calculate the Hubble constant. We spent the late 20th and early 21st centuries using the Hubble Space Telescope to meticulously climb this ladder. We stared into the dark for thousands of hours, isolating the faint, rhythmic beating of distant Kephids and waiting for the catastrophic flash of dead stars. And after decades of relentless observation, the numbers stabilized. The cosmic distance ladder gave us a highly refined, heavily tested measurement for the current expansion rate of the universe. The number was roughly 73.2 kilometers per second per megaparsec. This meant that for every 3.26 million light-years, you look deeper into the void. The fabric of space is expanding roughly 73 kilometers per second faster. The measurement was solid. The local universe was expanding at a speed of 73. But there is a second way to calculate the expansion of the universe. A method that completely bypasses the messy, chaotic physics of pulsing stars and exploding white dwarfs. A method that looks back to the absolute beginning of time itself. To understand the universe, we do not just look out, we look back. Because light takes time to travel, staring into deep space is literally staring into the deep past. If you look far enough, past the galaxies, past the oldest stars, you eventually hit a wall of absolute radiation. You hit the residual heat of the Big Bang. This is the cosmic microwave background, the CMB. It is the oldest light in existence. Fossilized radiation from a time when the universe was just 380,000 years old. In its infancy, the universe was not the cold, expanding vacuum we know today. It was a suffocating, infinitely dense, blindingly hot soup of plasma. It was so dense that light itself could not travel. Photons were permanently trapped, endlessly colliding with a chaotic sea of free electrons. But as the universe expanded, it cooled. And at the exact moment it cooled to roughly 3,000 degrees, the chaos stopped. The electrons suddenly bound themselves to protons, forming the first hydrogen atoms. The fog lifted. The universe became transparent, and the trapped light was finally released, flashing out in every direction simultaneously. That first flash of light is still traveling through the cosmos today. But as the fabric of space has stretched over the last 13.8 billion years, the wavelength of that ancient light has been stretched with it, shifting it far beyond the visible spectrum, down into the cold, faint hum of microwaves. The universe is literally bathed in this frozen afterglow. Between 2009 and 2013, the European Space Agency operated an instrument called the Planck satellite. It was stationed in deep space, chilled to near absolute zero, designed to scan the entire sky and map the cosmic microwave background with terrifying, unprecedented precision. It measured microscopic temperature fluctuations in the ancient radiation, spots that were slightly hotter or slightly colder by mere millionths of a degree. These microscopic fluctuations are the literal acoustic echoes of the Big Bang. In the primordial plasma, gravity was trying to pull matter together, while the intense heat of radiation was pushing it apart. This monumental tug-of-war created massive sound waves, baryon acoustic oscillations that rippled through the newborn universe like ripples in a pond. When the universe suddenly cooled and became transparent, those sound waves were instantly frozen in place, locked into the radiation as a pattern of hot and cold spots. By analyzing the exact size and distribution of those spots, physicists can extract the fundamental genetic code of the cosmos. The Planck data gave us the exact ratio of dark matter to normal matter. It gave us the precise curvature of space-time. It gave us the blueprint from which all future galaxies would grow. It is the ultimate baseline. Our theoretical framework, the standard model of cosmology, takes this flawless baby picture of the universe and uses the known laws of physics to fast-forward the tape. We input the precise conditions of the Big Bang, run the mathematics of gravity, radiation, and dark energy, and simulate how the universe must have expanded over the next 13 billion years. The model is so rigorous, and the Planck data is so impeccably detailed, that it produces a mathematically undeniable prediction for exactly how fast the universe should be expanding today. It predicts the Hubble constant with extreme surgical precision. According to the ancient light of the Big Bang, run through the most successful theoretical framework in human history, the universe should be expanding at a rate of 67.4 kilometers per second per meter. And right there, hidden in the decimals, is the crisis that is currently tearing astrophysics apart. The early universe predicts an expansion rate of 67.4. The modern local universe, measured by the physical detonation of stars, yields an expansion rate of 73.2, a difference of about 6 units. To the uninitiated, it sounds trivial. It sounds like a rounding error, a minor disagreement between two highly complex instruments. But in the cold, unforgiving realm of statistical physics, this discrepancy is an apocalyptic event. In science, we measure the reliability of data using standard deviations, referred to as sigma. A 1 sigma discrepancy implies there is about a 30% chance that the difference is just random noise, a fluke of the instruments. A 3 sigma discrepancy means the data is highly suspect, with only a 0.3% chance of being a statistical accident. The difference between the early universe measurement and the late universe measurement is a 5 sigma discrepancy. In particle physics, a 5 sigma result is the gold standard required to declare the absolute discovery of a new law of nature. It means the probability that this difference is a random error, a fluke in the data, or a mistake in the telescopes, is roughly 1 in 3.5 million. The margin of error on both sides has shrunk to the point where they no longer overlap. They are mathematically isolated from one another. Both measurements are brilliant. Both measurements are precise. Both measurements have been checked, rechecked, debated, and independently verified by thousands of the brightest minds on the planet over the course of decades. There is no missing variable in the telescope calibration. There is no smudge on the lens. The horrific truth of the 5 sigma threshold is that both numbers are entirely correct. The universe was born with a genetic code that dictates it must expand at a speed of 67. But the physical universe we are actually living in is ripping itself apart at a speed of 73. This is the Hubble tension. It is not an error in observation. It is a fundamental paradox in the architecture of reality. It means that the unbreakable bridge connecting the beginning of time to the present day, the very laws of physics themselves, is fundamentally fractured. We are missing something monumental. There is a phantom gear in the machinery of the cosmos, a terrifying, invisible mechanism that has dramatically accelerated the expansion of the void while we were not looking. For years, the scientific community clung to a single, desperate lifeline. They hypothesized that the problem was not the universe, but the limitations of the Hubble Space Telescope itself. The cosmic distance ladder relies heavily on Cepheid variables, But observing these stars in highly congested, incredibly distant galaxies is mathematically treacherous. Hubble's vision, as magnificent as it was, had a resolution limit. When peering deep into the crowded stellar nurseries of ancient galaxies, the light from a target Cepheid variable would often blur together with the light of neighboring stars. It was a phenomenon known as stellar crowding. Astronomers had to write complex software algorithms to artificially subtract the contaminating background light and isolate the specific pulse of the target star. Many theorists argued that this subtraction process was flawed. They argued that Hubble's blurred vision was artificially inflating the brightness measurements, creating a phantom acceleration that did not actually exist. The entire foundation of the crisis, they hoped, was just an optical illusion born from the atmospheric limits of an aging, 30-year-old satellite. The argument provided a psychological shield against the terrifying implications of broken physics. All we needed was a new eye. A telescope engineered with such ruthless, unprecedented precision that it could pierce the cosmic dust, cut through the stellar crowding, and isolate the exact uncontaminated pulse of individual stars located hundreds of millions of light-years away. We needed an instrument operating in the infrared spectrum, capable of looking through the obscuring fog of deep space with absolute clarity. We needed the James Webb Space Telescope. When the golden mirrors of Webb finally unfolded in the freezing dark of Lagrange Point 2, perfectly aligned to a fraction of a nanometer, the entire astrophysical community held its breath. The telescope was pointed at the exact same distant galaxies Hubble had measured. It was tasked with analyzing the exact same Cepheid variables, to resolve the blur, correct the data, and finally close the gap between the early universe and the late universe. We expected Webb to fix the math. We expected it to erase the tension and restore order to the cosmos. When the data streams from the James Webb Space Telescope finally began to render on the screens of astrophysicists around the world, there was no celebration. There was no triumphant press conference declaring that the grand mystery of the cosmos had been solved. There was only a profound, chilling silence. For years, the scientific community had heavily relied on the comforting assumption that the Hubble tension was simply a ghost in the machine. They had convinced themselves that the aging optics of the Hubble Space Telescope were blurring the starlight in distant, overcrowded galaxies, creating a phantom acceleration that did not actually exist. The James Webb Space Telescope was engineered specifically to pierce through this exact illusion. With its monumental array of gold-plated beryllium mirrors operating in the near-infrared spectrum, Webb possessed the unprecedented ability to see straight through the dense, obscuring clouds of interstellar dust that blinded older telescopes. It was designed to look at the exact same distant galaxies Hubble had observed, to isolate the precise, rhythmic beating of individual Cepheid variable stars with surgical clarity, and to finally correct the math. We expected the most advanced instrument in human history to prove that the universe was behaving exactly as our models predicted. Webb locked onto the distant galaxies. It bypassed the stellar crowding. It isolated the target stars with ruthless precision. And the data it sent back was mathematically devastating. The numbers were identical. The error was not human. The calibration was flawless. The local modern universe is indeed tearing itself apart at a rate of roughly 73 kilometers per second per megaparsec. The discrepancy is brutally real, and with Webb's confirmation, the statistical certainty has shattered the 5 sigma barrier, pushing the probability of an observational error to an absolute zero. The tension is no longer an anomaly. It is a fundamental paradox woven into the fabric of reality. To understand the terrifying gravity of this paradox, we must look at the fragile architectural framework that holds our entire understanding of physics together. It is a mathematical model known as the Standard Model of Cosmology. This model is the grand unified recipe of the universe. It dictates that the reality we experience, the stars, the planets, the glowing nebulae, the black holes, and the very chemistry of our own bodies accounts for a mere 5% of the total universe. We are nothing but a microscopic layer of foam riding on the surface of an invisible, fathomless ocean. The rest of the universe is divided into 2 invisible, deeply mysterious components. 27% is cold dark matter. We cannot see it, we cannot touch it, and it does not interact with light. We only know it exists because we can observe its massive gravitational grip holding spinning galaxies together, preventing them from flying apart like loose sand on a centrifuge. The remaining 68% of the universe is an even more sinister entity. It is the cosmological constant, more commonly known as dark energy. Dark energy is the engine of the apocalypse. It is the invisible, repulsive force that acts entirely counter to gravity. While gravity tries to pull the masses of the universe together, dark energy exists within the empty vacuum of space itself, actively pushing the fabric of reality apart. The Standard Model relies on a highly specific, delicate thermodynamic balance between the gravitational pull of dark matter and the repulsive outward push of dark energy. If you take the flawless baby picture of the universe from the cosmic microwave background and feed it into this model, the mathematics flawlessly predict the formation of the cosmic web. It predicts how gas clouds collapse into stars, how galaxies cluster together along invisible dark matter filaments, and crucially, exactly how fast the dark energy should be stretching the void today. But the data from the James Webb Space Telescope proves that this perfect mathematical recipe is completely, catastrophically broken. Imagine you are a senior network engineer diagnosing a massive latency issue across a global server array. You know the exact physical distance between a server in New York and a server in Tokyo. You know the absolute speed of light traveling through the fiber optic cables. Based on the fundamental laws of physics, you calculate that a data packet must take exactly 60 milliseconds to make the journey. You send the ping. But the server logs show the packet arriving in just 50 milliseconds. The data is verified. The timestamps are absolute. This leaves you with an impossible conclusion. Either the physical distance between New York and Tokyo has mysteriously shortened while you were not looking, or the fundamental speed of lighter universal constant has secretly changed its own rules. We are currently pinging the universe, and the astrophysical data packets are arriving with timestamps that violently contradict the core code of reality. The universe is speaking a language we thought we had mastered, but the fundamental vocabulary has shifted. If the early universe dictates an expansion rate of 67, and the local universe dictates a rate of 73, it means that our understanding of the 13 billion years stretching between those 2 points is missing a monumental phantom gear. The barrier we have hit is not technological. We have engineered the greatest eyes humanity could ever conceive, and they have functioned flawlessly. The barrier is entirely theoretical. The physics are mathematically contradicting themselves, forcing theoretical physicists into a desperate scramble to invent entirely new mechanics of reality, just to balance the cosmic ledger. We are watching the real-time collapse of a century of established astrophysics, and the new theories emerging from the wreckage are far more unsettling than the paradox itself. If the Standard Model is broken, something else must be driving the accelerated expansion. The first, and perhaps most desperate, theoretical patch proposed by astrophysicists is the concept of early dark energy. To make the math of the ancient cosmic microwave background match the violent, accelerated reality of the modern universe, theorists have suggested that the dark energy we experience today is not the only dark energy that has ever existed. They hypothesize that roughly 100,000 years after the Big Bang, during the suffocating, chaotic plasma era of the infant universe, a massive, transient field of phantom energy suddenly blinked into existence. It acted like a catastrophic thermodynamic fever. For a brief, terrifying window of cosmic time, this early dark energy violently overpowered gravity, massively accelerating the expansion of the newborn universe. It is as if the cosmic machinery experienced a brief, violent slippage in its transmission, revving the engine of expansion to a terrifying red line, fundamentally stretching out the acoustic sound waves frozen in the primordial plasma. Then, just as suddenly as it appeared, this phantom energy field decayed. It vanished into the quantum background, dropping the universe back into a normal gear, leaving behind an altered genetic code that would eventually evolve into the 73 km/s expansion rate we see today. Early dark energy solves the Hubble tension perfectly on paper. It mathematically forces the two conflicting measurements to shake hands. But it requires a massive, uncomfortable leap of faith. It requires us to invent a brand new, invisible physical force that existed solely for a fraction of cosmic time, altered the fundamental architecture of the void, and then completely erased its own tracks, never to be seen again. In the cold, unforgiving realm of theoretical physics, introducing a ghost particle just to balance an equation is considered a dangerous, almost heretical compromise. It feels less like a discovery of truth and more like a mathematical sleight of hand designed to protect our fragile egos from the terrifying realization that we simply do not understand gravity. Which brings us to the second, far more unnerving barrier. What if the problem is not a phantom energy pushing the universe apart, but a fundamental failure in the glue that holds it together? What if our entire understanding of gravity is wrong? For over a century, Albert Einstein's theory of general relativity has been the undisputed king of astrophysics. It has passed every single observational test humanity has thrown at it. It perfectly predicted the bizarre shifting orbit of Mercury. It predicted the bending of starlight around massive galaxies. It even predicted the existence of gravitational waves, microscopic ripples in the fabric of space-time generated by the violent collision of black holes, which we finally detected a century later. General relativity is the absolute bedrock of modern physics. But general relativity was formulated based on observations made within the microscopic confines of our own solar system. It works flawlessly at local scales. The barrier arises when we arrogantly assume that the mathematical rules governing a single planetary system must universally apply to an infinite, stretching void spanning billions of light years. Some physicists are now staring into the abyss of the Hubble tension and suggesting the unthinkable, that at massive, cosmic scales, the laws of gravity begin to break down. This concept, known as modified Newtonian dynamics or modified gravity, proposes that the tensile strength of space-time itself might have limits. At the incomprehensible distances separating galaxy clusters, the gravitational tether might simply weaken in ways Einstein's equations did not predict. If gravity is inherently weaker over vast distances, it would offer less resistance to the natural expansion of the universe, allowing the cosmos to fly apart much faster than the standard model anticipates. But modifying gravity is mathematically equivalent to pulling the bottom card out from a towering house of cards. If you change the equations of general relativity even slightly to fix the Hubble tension, you instantly ruin a dozen other cosmological observations that rely on Einstein's original math. You fix the expansion rate, but suddenly your models for how galaxies rotate fall apart. You fix the expansion rate, but suddenly your calculations for the age of the oldest stars make no sense. We are trapped in a mathematical straitjacket. Every attempt to pull at a thread to loosen the tension only tightens the knots somewhere else. This relentless frustration leads us to the final and unequivocally most terrifying theoretical explanation for the anomaly. It is a concept that strikes at the very heart of what dark energy actually is, and it threatens to rewrite the ultimate destiny of everything in existence. When Einstein introduced the cosmological constant, he envisioned it as exactly that, a constant. The standard model assumes that the density of dark energy in the vacuum of space never changes. This means that if you take a single cubic meter of empty space, it contains a highly specific, unchanging amount of dark energy pushing outward. As the universe expands, more cubic meters of empty space are created. Because there is more total space, there is more total dark energy, which causes the expansion of the universe to accelerate. But crucially, the energy per cubic meter remains exactly the same. It is a steady, relentless, proportional acceleration. In thermodynamics, the behavior of this mysterious vacuum energy is defined by an equation of state. In the standard model, the equation of state for dark energy is calculated to be exactly -1. This perfect -1 guarantees that dark energy is a stable, constant force, an immutable law of the void. But the precise data currently bleeding from the sensors of the James Webb Space Telescope allows for a chilling alternative. The data suggests a mathematical margin where the equation of state might not be exactly -1. It leaves room for the possibility that it is actually slightly less than -1. In the rigid logic of theoretical physics, if it drops below -1, the fundamental nature of reality turns into a nightmare. It means the dark energy is not a constant. It means we are dealing with phantom dark energy. Phantom dark energy is a thermodynamic horror. It dictates that as the universe expands, the dark energy does not just increase in total volume, it increases in density. The energy packed into every single cubic meter of empty space is actively growing stronger, multiplying and compounding over time like a malicious, inescapable cosmic interest rate. It means that the universe is not just accelerating. The acceleration itself is accelerating. This is the ultimate barrier. The Hubble tension might not be a glitch in our math or an error in our telescopes. It might be the first distant early warning siren of an escalating infection within the vacuum of space. We are measuring a discrepancy between the early universe and the late universe because the rules of the void are actively mutating in real time. The phantom energy is a rogue variable, a force that feeds on the very expansion it creates, growing exponentially more violent with every passing millennium. We built the James Webb Space Telescope to find absolute, static truth in the dark. We demanded that the universe yield a logical, orderly set of equations that we could write in textbooks and teach to our descendants. Instead, we have spent $10 billion to effectively drag a stethoscope across the chest of the cosmos, only to hear a heartbeat that is violently, dangerously out of rhythm. The cathedral of physics is not just collapsing. Its very blueprints are being rewritten by an unseen author. We are apes who learned to do calculus, staring wide-eyed at a colossal, indifferent machine that is actively altering its own mechanics while running at full speed. We are no longer simply observing the void. The void is accelerating away from our comprehension, leaving us entirely exposed to the dark, unresolved mechanics of a universe that does not care about our need for mathematical harmony. When the bedrock of physics begins to fracture, the resulting devastation does not remain neatly confined to the abstract chalkboards of theoretical cosmologists. The ripple effects bleed downward into the very fabric of our everyday existence, methodically destroying the most fundamental, comforting assumption humanity possesses: the illusion of permanence. If the Hubble tension is not merely an optical glitch born of faulty lenses, if the engine of the universe is truly running on a mutating phantom energy, then we are forced to confront a deeply unsettling reality about time and our ultimate trajectory. We have always treated time as a steady, unilateral progression, a quiet river carrying us forward into a predictable future. We assumed that the destiny of the cosmos was simply a colder, wider, older version of its present state. But phantom dark energy destroys that timeline. It introduces a catastrophic, rogue variable into the thermodynamic evolution of reality. The universe is not simply coasting outward on the residual momentum of the Big Bang, slowing down as it expands. It is actively hitting the accelerator, and in a universe where the vacuum of space is continuously compounding its own repulsive force, the future becomes mathematically terrifying, because space and time are physically woven together into a single fabric. You cannot violently warp one without permanently distorting the other. The accelerating expansion fundamentally alters the arrow of time on a cosmic scale. The first, inescapable consequence of this escalating velocity is an event that is already happening. Quietly, relentlessly, in the extreme depths of the night sky. The universe is actively erasing its own history. Because the fabric of space is stretching, the galaxies embedded within that space are being carried away from us. And because the rate of that stretching is accelerating, the speed at which those galaxies retreat is constantly, mercilessly increasing. Eventually, a galaxy is pushed so far out into the void that the space between us and that galaxy is expanding faster than the speed of light. This does not violate the laws of relativity. The physical stars are not moving through space faster than light. Rather, the empty space itself is multiplying faster than the light can cross it. It is like trying to run backward on an escalator that is continuously speeding up. No matter how fast you run, the distance between you and the top only grows. When this mathematical threshold is crossed, the galaxy slips beyond what astrophysicists call the cosmological event horizon. It becomes permanently invisible. Its light will never, ever reach us again, no matter how long we wait, no matter how impossibly massive our telescopes become. It is a physical, unbreakable quarantine. Right now, exactly as you are listening to this, entire clusters of ancient galaxies are slipping over that edge. Every single second of every single day, massive star systems containing billions of burning suns, potentially harboring countless worlds and silent civilizations, are crossing the boundary of observation. They are winking out of mathematical existence, permanently lost to the expanding dark. We are living inside a rapidly shrinking sphere of observability. If humanity had evolved a few billion years later, the sky would be completely empty. We would look up into the night and see absolutely nothing but the dead, black silence of our own isolated galaxy. The evidence of the Big Bang, the faint echoes of the expanding universe, the chemical barcodes of distant nebulae, of it would have already been pushed entirely beyond the horizon. We would have no way of knowing that a larger universe ever existed. We are extremely fortunate to exist in this narrow, fleeting window of cosmic time, where the grand architecture of reality is still partially visible. But that window is violently closing. The universe is physically isolating us, cutting our sector of space off from the rest of existence. But this crushing isolation is merely the mildest symptom of a cosmos, infected by a phantom equation of state. If the dark energy density in the vacuum of space continues to multiply, the accelerated expansion will not stop at the edges of the observable universe. The repulsive force will eventually become so dense, so overwhelmingly powerful, that it will begin to turn inward. It will come for the local structures. This is the ultimate, apocalyptic conclusion of the James Webb data. It is a mathematical endgame, known in theoretical physics as the Big Rip. In the standard model of a gently expanding universe, the gravitational glue holding galaxy clusters together is incredibly strong. It is more than enough to resist the outward push of normal dark energy. The empty space between the clusters stretches, but the clusters themselves remain perfectly intact, bound by the immense weight of dark matter. But if the dark energy is a phantom force, growing exponentially stronger with every passing millennium, there will come a precise, calculable moment when the outward pressure of the vacuum overpowers the inward grip of gravity on a localized scale. The timeline of the Big Rip is a meticulously mapped descent into absolute structural disintegration. It does not happen in a single, sudden flash. It is a slow, methodical dismantling of physical reality, scaling down from the macro to the micro. Billions of years from now, the night sky will have already gone entirely dark, wiped clean of all other galaxies. The Milky Way and Andromeda, having long since merged into a single elliptical giant, will drift entirely alone in an infinite black ocean. Then, the compounding phantom dark energy will reach a critical threshold within our own galactic halo. The immense invisible dark matter filaments and the gravitational tethers holding our galaxy together will begin to stretch, warp, and snap. The outer stars will be peeled away first, violently cast out into the accelerating void. The spiral arms of the galaxy will dissolve. The night sky, previously dense with the familiar, comforting glow of our neighboring stars, will rapidly begin to thin out until the stars themselves are rushed away from our solar system faster than the speed of light. But the engine of the vacuum does not stop at the galactic scale. As the phantom energy continues its exponential, runaway surge, the repulsive force will eventually breach the boundaries of our own solar system. It will overpower the gravitational well of the Sun. The planets will be stripped from their ancient orbits. Earth will be violently detached from the Sun's anchor, plunging out into a freezing, starless dark. Months before the absolute end, the dark energy will overpower the gravitational binding of the Earth itself. The planet will not simply shatter, it will be pulled apart at the planetary seams. The crust will fracture in global cataclysmic fault lines. The mantle will be ripped outward into the vacuum, and the dense iron core will dissolve into a cloud of accelerating, expanding debris. In the final hours, the expansion of the universe will reach the electromagnetic scale. The atomic bonds holding complex molecules together will fail under the immense negative pressure. The proteins in biological matter, the silicates in pulverized rocks, the metallic structures of human engineering scattered among the dust of it will violently disassociate. In the final fraction of a single second, the phantom energy will overpower the strong nuclear force. The fundamental building blocks of matter itself, the protons and neutrons, will be physically ripped apart into a spray of raw quarks. And instantaneously, those individual quarks will be isolated from one another by the infinitely accelerating expansion of space. The universe will not end in a fiery, crushing collapse, nor will it gently fade into a long, quiet heat death. It will end in a state of violent, microscopic isolation. Every single subatomic particle in existence will be permanently separated by an infinitely vast, infinitely expanding gulf of empty space, completely incapable of ever interacting with another particle again. Reality will be reduced to a completely sterile, frozen mist of elementary particles, flying apart at incomprehensible speeds in total, absolute darkness. This is the shadow that the James Webb data has cast over modern astrophysics. By confirming the Hubble tension and proving that the expansion is accelerating beyond our standard models, Webb has validated the mathematical pathway that leads directly to this catastrophic disintegration. It has proven that the calm, orderly cosmos we thought we inhabited was a profound, arrogant illusion, born of our own fleeting perspective. We are not living in a stable, architectural masterpiece. We are passengers on a colossal machine that is currently in the process of tearing its own gears to shreds. And the most terrifying aspect of this realization is the absolute impotence of human knowledge in the face of it. For centuries, we have constructed vast intellectual empires to understand our place in the dark. We built sprawling subterranean particle accelerators, burying them under the earth to smash atoms and recreate the fires of the Big Bang. We engineered hypersensitive laser interferometers, stretching for miles across the desert, just to catch the microscopic, invisible ripples of colliding black holes. We launched massive golden mirrors 1,000,000 miles into the freezing vacuum of space to read the chemical barcodes of ancient, dying starlight. We did all of this to convince ourselves that we could outsmart the sheer, overwhelming scale of reality. We believed that if we could just write down the correct, elegant equation, we could tame the void. We thought the universe was a puzzle to be solved, a rational code to be broken by human intellect. But the expanding discrepancy in the Hubble constant suggests something far more sinister. It suggests that the universe is not a puzzle. It is an actively shifting, mutating labyrinth. The moment we think we have perfectly mapped its corridors, the walls physically move. The laws of physics are not a permanent, unshakable constitution. They are a localized, temporary weather pattern in a much larger, incomprehensibly hostile environment. We are forced to confront the chilling possibility that human science might have a hard, physical limit. There might be a definitive boundary to our understanding, not because our brains are too small, or our machines are too weak, but because the universe itself is actively conspiring to erase the evidence of its own mechanics. Burying its secrets behind a wall of accelerating space, we are watching the horizon rush toward us, helpless to stop the stretching of the void. We are a species uniquely burdened by our own capacity to comprehend our eventual erasure. Throughout the brief, chaotic history of human civilization, we have instinctively sought to place ourselves at the center of a grand, enduring narrative. We built monolithic observatories to track the equinoxes. We traced mythical figures across the constellations. And we convinced ourselves that the cosmos was an architectural theater constructed specifically for our observation. Even as our instruments pushed the boundaries of the known world outward, revealing billions of other galaxies scattered across the abyss, we clung to a comforting delusion of permanence. We believed that as long as the stars continued to burn, there would be a stable stage for existence to play out. The anomaly in the dark has completely dismantled that comfort. The accelerating expansion of the void is not merely a mathematical curiosity confined to the journals of astrophysics. It is a profound, inescapable verdict on the nature of our existence. It tells us, with brutal statistical certainty, that we are not the protagonists of reality. We are a temporary, localized accident. We are nothing more than a fleeting arrangement of thermal energy and complex chemistry, clinging to a dying spark, caught in the undertow of an unimaginably vast and entirely indifferent mechanical process. When we look up at the night sky, our intuition tells us we are seeing a permanent legacy. We see the majestic rotation of galactic disks and the ancient light of a universe holding its shape. But the data has confirmed that what we are actually looking at is a vanishing illusion. The universe is methodically closing its own doors. It is actively pulling the distant stars away from us, faster than their light can ever cross the gulf. The great cosmic web is being pulled violently taut. There is no hidden equation, no grand unified theory that will step in to stop the phantom energy from compounding in the vacuum. The dark energy that is currently expanding the microscopic space between your very atoms does not possess malice, nor does it possess mercy. It is a cold, fundamental property of a cosmos that is actively marching toward an absolute and terrifying isolation. In the distant future, long after the last star has exhausted its final reserves of nuclear fuel and faded into a black cinder, the sky will not simply be dark, it will be profoundly empty. The physical bridge between all matter will be severed. No particle will ever interact with another particle again. The memory of everything that has ever existed, every empire that rose and fell, every brilliant piece of mathematics, every monument we engineered to defy, time will not just be forgotten. It will be physically erased from the geometry of space itself, dissolved into a permanent, freezing mist of completely isolated subatomic dust. We engineered the greatest eyes humanity could conceive, launching them into the depths of space, desperately hoping to find a reflection of our own order. We wanted the universe to be logical. We wanted the math to finally balance. Instead, we found the precise mechanism of our own absolute unmaking. We have finally measured the true, terrifying pulse of the dark. And it is accelerating, pulling everything apart, leaving us entirely alone in the expanding silence.